Hello and welcome back to the Electricity Conference, where we'll be talking about communities. My name is Helen Seagrave and I'm the Community Energy Manager at Electricity North West, so this is something that's important to me. First, we'll be hearing from two innovation projects that involve a high degree of community engagement from Western Power Distribution and Northern Power Grid. We will then go on to a panel discussion on protecting vulnerable customers as we decarbonise electricity networks, an issue that is a major priority for Ofgem and for Britain's energy networks and is becoming increasingly important as we move towards the ED2 regulatory period. For our audience, you can be part of the discussion too by commenting or typing your questions into the chat facility to the right of your screens. Our speakers are logged in and ready to answer all your questions. That's it from me for now, so I'll hand over to our presenters.
Hello, my name is Sam Rossi Ashton and I've been an Innovation and Low Carbon Networks Engineer at Western Power Distribution for a little over 2 years. I currently project manage our OpenLV, EFS and Presumed Open Data projects. The following presentation is a snapshot into our OpenLV Network Innovation Competition project, which is now drawing to a close. More specifically, the presentation will look at how distributed intelligence on the low voltage network has benefits not only for the network itself, but also wider stakeholders such as community groups.
This slide serves to summarise what I'm going to try and cover in today's session. It details WPD Innovation Team's strategies, values, commitments and priority areas, the project overview, the concept, the three methods the project pursued, which were network capacity uplift, community engagement, extensibility, then followed by an animation that we've had developed as part of the project dissemination activities, learning, the project success, and next steps.
The role of the innovation team within Western Power Distribution is to identify problems and develop solutions to those problems, with the aim of them then being deployed within the wider business if proven successful. The way in which we do this and our progress is outlined within our innovation strategy, which is published annually. The work that we do always adheres to our core values of contributing to decarbonisation, achieving excellence and providing value for money. Our commitments as a team are to overcome barriers to the energy transition, continue to focus on finding novel ways of efficiently and effectively transforming the network, continue to develop new technologies, commercial solutions and standards to make the most of our existing network, and work with communities to understand how best we can support our vulnerable customers and ensure that there is no one left disadvantaged. The innovation team has 5 priority areas of decarbonisation and net zero, heat, transport, communities and customer vulnerability, and data. Each one of our projects adheres to at least one of these areas. The team is currently delivering a comprehensive programme of projects covering all areas of energy transition. Some of our projects are displayed on screen now, and if you want any more information about any of them, please contact me afterwards. To first give you an overview of the project, OpenLV was funded via the Network Innovation Competition. It started in 2016 and is planned to end in December of this year, 2020. Its budget is £5.4 million and its primary partner is EA Technology, but Nortec, Lucy Electric, the Centre for Sustainable Energy, Regen and the NCC Group were also partners to this project. The project concept was to deploy distributed intelligence in the form of a flexible platform onto the electricity network to trial an app-based approach to interacting and managing it. Apps have revolutionised the way in which we use various other devices, enabling multitudes of providers to deploy solutions at scale remotely to fit different specific needs, and the project sought to apply this concept to the electricity industry. The project looked to trial this concept in 3 distinct methods. Firstly, network capacity uplift, which sought to evidence automated and decentralised network control. The second method was to engage with communities to realise what benefits they could attain using local network data.
And the third investigated the appetite for third parties to develop apps for either network or other benefits. Network capacity uplift looked at load sharing between substation pairs, which are substations that can be connected via a normally open point by meshing them. This would occur when one transformer or substation is highly loaded, enabling its pair to share the load. Firstly, substation pairs were identified in a variety of network types. Then project equipment that consisted of a network monitor and a ruggedized computer was deployed at 25 pairs of substations. Rather than immediately automating meshing, these 25 pairs were instead monitored, assessed and optimized. Later in the trials, 5 pairs were taken forward to be meshed in an automated fashion. This was done by the project computers communicating with one another using real-time thermal ratings to indicate the need for load sharing. They were meshed using an EA technology Alvin reclose unit. In Method 2, which was dubbed Community Engagement, our project partner, the Centre for Sustainable Energy, first gathered interest from community groups and then chose a number of these groups to participate based on a broad range of use cases. The project made available 10 LV cap units to deploy to facilitate these use cases. Note that some groups use more than one unit. The project initially intended for the community groups to develop their own app from the data, but limited app development skills and resources meant that the project chose to instead develop a single app that would facilitate all community use cases. Regen did some great analysis on the value and benefits that the projects and app offered to communities. These can be summarised into 3 different areas. The first of which is transparency value. Communities having access to OpenLV data means that they can identify opportunities such as time of use tariffs, assess and evaluate plans for distribution-connected projects and investments. The second was engagement value. OpenLV data helped build communities' knowledge of energy infrastructure, energy consumption, and how that consumption can be changed to reduce carbon emissions. The third value was flexibility. OpenLV data and functionality supports community-level aggregation and the coordination of community-led demand-side response. This can enable community to derive additional revenue from participating within flexibility services offered by Western Power Distribution. Method 3, dubbed Extensibility, looked at how business and academia could utilise the concept of a flexible and open platform. During this method, workshops were first held with the potential participants prior to applications being made by them. 16 business applications and 9 academic institutions were chosen as participants. 6 of these looked to deploy an app onto the platform itself, with the rest looking to use the project data off-platform. Once chosen, participants were provided with information and support, as well as an app development toolkit, an API, and data system access. The developments and research was funded by third parties themselves. The developments ranged from capacity management use cases to consumer care to network health. Ultimately, 6 apps were developed and deployed, and 6 academic research papers were published as part of the project. Now you'll see an animation that has been developed as part of the suite of the project's dissemination materials.
The way we use electricity is changing. We own more domestic appliances and devices such as smartphones and tablets than ever before. Many of us have installed low-carbon technologies like solar panels and are switching to electric vehicles. In the future, we're also increasingly likely to use electricity for heating. All of these choices have impacts for local electricity networks. To meet increased demand for electricity and to support low-carbon generation, we need to work smarter. And to do that, we need more data. Data gives us a better understanding of our electricity use and helps to manage the network more efficiently. The OpenLV project opened up data in electricity substations for the first time by trialling an open software platform. This monitored performance and electricity demand, performed locally managed network control, and hosted apps that could benefit everyone. The project gathered around 15 million data points every day from 80 substations across our regions in the Midlands, South West England and South Wales. Volunteer community organisations, businesses and universities developed apps or were given access to data which was used in a variety of ways. Volunteer organisations used it to educate school children, increase understanding about energy use among communities, control EVs, and investigate ways of connecting more renewables to the electricity network. Since the project ended, community organisations have continued to use the network data and the web app developed for them to advance their zero carbon ambitions and help their communities use energy more efficiently. A guidebook has also been developed to help other community groups learn from their experiences. Network operators are expanding their use of data to improve their understanding of their networks and make informed investment decisions. Work is also underway to develop a commercial platform that will enable businesses and universities to develop apps and access data, allowing innovative solutions to be developed for the wider industry. OpenLV has opened the door to a future where software platforms can be used by network operators to make data available to businesses, community organisations and others. This data will help to connect more decentralised renewable generation, and where electricity is being produced locally will enable signals to be sent to charge EVs and heat homes, helping to cut costs for consumers and benefit the environment. The OpenLV project has played an important part in moving the UK closer to a smart grid, helping to minimise network upgrade costs and paving the way for a future in which everyone can benefit from our journey to net zero.
The project learning gathered throughout the methods and trials has been comprehensively documented in reports, all of which are available on the WPD Innovation website. But for the purposes of this presentation, I've tried to distill the headlines into a few points. OpenLV proved that distributed intelligence can perform automated network control in a safe and secure fashion. An open, flexible platform deployed widely throughout distribution networks can be used to benefit not only networks via control and automation, but also business, academia, communities, and its wider customers. There is significant interest from third parties in not only the use of network data, but also the development of apps for open platforms where batch and remote deployments makes this easy. Project analysis has suggested that wider rollout of such platforms would not only empower communities and network users, but also has the potential to reduce network expenditure by over 1.8 billion by 2050. The project's achievements over the last few years can be further summarised into the following. It has empowered communities, providing accessible data that has helped third parties to better understand their energy behaviour, manage their consumption and reduce environmental impacts. The project has facilitated new business models. Apps developed can now be used to support non-traditional business models where third parties can deploy new solutions using a better understanding of the network. The project has also improved the network for customers. Project data has been used to improve the network by optimising the deployment of community-owned low-carbon technologies and released capacity on the network. As the project draws to a close, we are now embarking on activity to ensure that the solution lives on. We're developing an arrangement that will allow new apps to be deployed onto LVCAP platforms. In regards to communities, WPD has now replaced the community project systems with a business as usual equivalent provided by EA Technology. WPD is also now currently developing an offering whereby new community groups will be able to access the functionality developed as part of the CSE community app post-project. Additionally, WPD is always looking for ways to empower its customers. We plan to make the OpenLV dataset publicly available and processed to the extent it's widely accessible for future learning. This draws to the end of the presentation. Thank you for listening. I've been Sam Rossi Ashton, an Innovation and Low Carbon Networks Engineer for Western Power Distribution, and my email address is below should you have any further inquiries in regards to the project. Thank you very much.
Hello everybody, and thank you for attending this session on Northern Power Grid's Boston Spa Energy Efficiency Trial. My name is Francis Shillito and I'm the Project Manager. Firstly, a bit of background on how the project came about. One of our senior executives, Patrick Irwin, was approached by a member of the public at a DNO stakeholder engagement event. Now this gentleman had built a new house in Boston Spa, a market town located between Leeds and York, and saw that the supply voltage was quite high. He used to work in the industry and is familiar with the concept of conservation voltage reduction, whereby reducing the voltage by a few percent can lead to an equivalent reduction in energy consumption. He actually installed a voltage regulator at his property to do this, and he wanted to know why DNOs generally run the voltages on their LV networks towards the top end of the allowable limits. So we started off by analysing some of the smart meter half-hour voltage measurements in the Boston Spa area, and indeed we found that the network was generally run towards the top end of the allowable ESQCR limits. Now it's a fairly well-established theory that by reducing the supply voltage by 1% can reduce energy consumption by between about 0.5% and 2%, depending on the types of load being supplied. This is taken advantage of by OC6 in the grid code, whereby grid can instruct DNOs to lower demand by tapping their supply point transformers. There is also a big market for voltage regulators in the industrial and commercial sectors where customers take their own steps to reduce the incoming supply voltage without affecting how their loads behave. In fact, there have also been innovation projects that have trialled conservation voltage reduction, and customers have not perceived any change to their quality of supply. We wanted to trial a novel method for applying conservation voltage reduction with minimal network investment. The solution we wish to trial works as follows. Starting at 1 on the diagram, we have smart meters measuring voltage every half an hour. These are sent up to our smart meter head-end system, Siemens Energy IP, 3 in the diagram, via the Arqiva Comms network and the Data Communications Company, the DCC. We are going to be developing something called the BEAT box, 4 in the diagram, BEAT standing for Boston Spa Energy Efficiency Trial. This will process these voltage measurements every 30 minutes and determine an optimal 11 kV voltage target set point for the 3 primary substations in the trial area. It will send this target voltage instruction to our network management system, Power on Fusion, 5 in the diagram, and the NMS will send the target voltage instructions down to the AVC relays at the 3 primary substations, labelled 6, and the AVC relays will tap the transformers, if required, to achieve the desired 11 kV target voltage. This will result in a change voltage at the customer's premises, which will hopefully be lower than what they currently receive. The project kicked off in April and is due to complete in 2023. We have been concentrating on 2 main areas so far. The first area is carrying out HV network studies in order to determine how far we can lower the voltage on the HV system. The second area is developing the operational technology architecture. This includes scoping and pricing the BEAT box, including the security hardening infrastructure required, the modifications to the smart meter gateway, the modifications to the NMS, installing super tap AVC relays at the 3 primary substations, and keeping up to date on the progress of enabling work such as the rollout of our SCADA IP network and rollout of SMETS2 smart meters in the trial area. We should be in a position to get full financial sign-off for the project in the new year. We'll spend 2021 developing the BEAT box algorithm and getting all the enabling work in place. This will also involve developing code snippets to test that the different systems can talk to each other and handle errors gracefully. We hope to have a fully functioning BEAT box installed and ready to trial in early 2022. We'll spend the first 3 months running the BEAT box in an open loop mode, where it is making target voltage set point decisions but not enacting them. Once we are happy that it can access sufficient smart meter data to make reliable decisions and can interact smoothly with the NMS, we will run the full closed-loop trial for 9 months, taking us up to the end of 2022. We'll then run a 3-month trial to see whether the beatbox conservation voltage reduction concept can be run in parallel with DSO services such as customer load active system services. There are a variety of challenges which we'll need to overcome for successful execution of the project. This will be the first time we have allowed an external system to send control commands to the network management system. This is a big step change to how the NMS is used by control staff and is perceived as a high-risk change, not only as it is a change to the operational philosophy of the NMS, but also due to the perceived cybersecurity risks. Being able to allow this to happen requires engaging with our control, operational technology and IT security staff. We have a project steering board with senior executive representation to ensure the project concepts are explained and agreed at a senior level. We also hold teleconferences with control, OT, IT security and software vendors to discuss the low-level detailed implementation. This ensures any problems or indeed disagreement in the technical implementation are brought out into the open and ways forward are agreed and documented. For those involved in projects requiring data to be extracted from smart meters, it will come as no surprise that the challenges are multiple. The majority of smart meters in the trial area are the earlier SMETS1 type, which cannot currently be interrogated by DNOs. Plans are afoot to enable DNOs to interrogate these meters, but whether this will occur quickly enough for our project or whether it will throw up further risks, we just don't know. So at present we are focusing on connecting to the approximately 750 SMETS2 meters in the trial area. Ad hoc testing, where we have pinged these smart meters, has demonstrated a low response rate with only approximately 200 responding to the ping request within 10 minutes. For the BEAT algorithm to carry out real-time control by polling for half-hourly smart meter voltage data, we need to be able to successfully poll the data from all the smart meters within a short time period. There are a number of links in the communications chain, including the DCC and the Arqiva radio network, any of which could be causing the problems. Another problematic area is the quality of the measurements the smart meters are taking. There is no agreement of where the decimal point should be placed for a voltage measurement between different manufacturer devices. Also, whilst energy consumption measurements must be clock synchronised to the half hour, there is no such requirement in the SMETS2 specification for voltage measurements. Whilst for some models of smart meters, the voltage measurement is clock synchronised to the half hour, for others the measurement could take place at any time in between. Perhaps the biggest challenge for us with regard to smart meters is that the SMETS2 specification does not provide an accuracy requirement for voltage measurements. Smart meter manufacturers are reluctant to provide any guidance on this, and the current rule of thumb is to consider voltage measurements to have an accuracy no better than plus minus 2%. This is pretty poor when you consider that we are obliged to keep LV customer point of supply voltages between plus 10% and minus 6%. I'd be interested to know if anybody has independently measured the voltage accuracy of smart meters and what they have found. Please put your findings in the chat box or email me afterwards. In the meantime, we are identifying locations where we have high accuracy LV voltage measurement devices installed in secondary substations and where there are SMETS2 meters in adjacent properties. For example, in the photo on this slide, we have a substation sandwiched between two houses, shown by the red rectangle, with one of these houses having a SMETS2 smart meter, shown by the red dot. There's only about 10 meters of cable between this house and the substation. We can compare the voltage measurements between the high accuracy metering units at the substation and the smart meter at the house at a time of low demand, when there is little voltage drop between the two, and use this to build up some metrics on SMETS2 voltage measurement accuracy. Another challenge is that we are obliged to continue supplying electricity to our customers for single circuit outages on the 11 kV network. To use an example, Leeds Road primary substation normally supplies the secondary substations up to the normally open point at Wotherson. If there is a fault on a cable section, the network will be reconfigured so that some of these substations will now be fed by Warren Lane. Control room staff maintain a live model in the NMS of exactly which secondary substations are fed by a particular primary substation at any point in time. They either address the switching points manually based on telephone conversations they have with field staff carrying out switching on the ground, or when there is remote comms to the substation, the status of the switches are updated in the NMS automatically. We are working with the supplier of our Power On Fusion NMS, GE, to be able to extract this live relationship between which secondary substation is being fed by which primary substation. Ultimately, the beatbox always wants to know which primary substations are driving the voltage for any particular smart meter where we are taking a measurement. We've carried out some modelling to determine what the LV busbar voltage is at all the secondary substations fed by any primary substation in the trial area under peak demand conditions and under HV single circuit outage conditions. In this modelling, the primary 11 kV bar voltage is maintained as a fixed 11.1 kV, as it is currently set. This graph shows voltage on the x-axis and the number of substation LV bus bars that are at that voltage on the y-axis. The vertical red dashed lines are the ESQCR plus 10% and minus 6% limits. The results for the HV system intact case is shown by the heavy bluish grey line. We can see that even under peak demand conditions there is scope to reduce the supply voltage, even taking into account any voltage drops on the LV network. We have also run the model for various outage scenarios shown by the other coloured lines. The problem in these instances is that there is a large variation in the voltage seen across the secondary substations fed from that primary. Thus, under outage conditions, there is little wiggle room with the voltages. So, it is important that the beatbox understands when and where outages are being taken and be able to react accordingly. The graph in this slide shows peak maximum demand conditions. Under minimum demand conditions, the voltages will be higher and less spread out. Thus, there will be more benefit to be realised by the beatbox implementing conservation voltage reduction. What we have found so far is that a dynamically controlled 11 kV level bar voltage is preferable to one that is statically fixed. We estimate that if we can provide a 1% voltage reduction to our customers, we can save them £5 per year on their electricity bills. A 4% reduction could save them £18 per year. Scaling up, if the beat concept was rolled out across Northern Power Grid's 2 licence areas, this would equate to customer savings of £18 million per year for a 1% voltage reduction and £70 million per year for a 4% voltage reduction. Extrapolating for Great Britain as a whole, with approximately 28.5 million customers, this equates to savings of £128 million per year for a 1% voltage reduction and £513 million per year for a 4% voltage reduction. The beat concept is not a capital heavy investment for DNOs, instead relying on plant and equipment that is already installed or will be installed due to smart grid and smart meter investments. We hope we've given you a bit of a flavour of the BEAT project. Keep an eye out on Northern Power Grid's innovation website for project reports. Feel free to contact us by email if you want to find out more or have any insights to add to the project. And finally, we hope you enjoy the rest of the conference.
Welcome back, everyone. For those of you who haven't already met me, I'm Randolph Brazier, Head of Innovation at the ENA, and welcome to this panel where we're going to be discussing protecting vulnerable customers as we decarbonise electricity networks. Today, I'm joined by 4 esteemed panel members who I'm going to quickly introduce now. First of all, we've got Dr. Elizabeth Blakelock, who's Principal Policy Manager for Energy Supplier Monitoring and Performance at Citizens Advice.
Hello, everyone.
Secondly, we've got Dr. Julia Privitera, Social Sustainability Strategy and Program Manager at UK Power Networks, one of our members.
Hello, everyone. Really pleased to be here today. Thanks.
We've then got Peter Smith, Director of Policy and Research at National Energy Action, or NEA.
Great to be with you guys on this very important agenda.
And then last but not least, we've got Councillor Kevin Freer, who's Chair of the Climate Emergency Network for the Local Governments Association.
Thank you very much indeed for inviting me today.
Brilliant. Thanks guys. So for this session, I'm going to ask each of our panelists to give a short overview, and then we're going to hopefully have one or two questions at the end. So each of the panelists are going to talk about how to go about protecting vulnerable customers. How do we make the future energy system fair? What are the opportunities to better engage with our customers in the future? So without further ado, I'm going to hand over to Elizabeth Blakelock first.
Thank you. So I'm going to talk to three areas. Firstly, identifying vulnerable consumers in the first place so you can protect them, listening to their needs and really understanding what they need in the moment. And then also I wanted to reflect a bit on pace, the pace that we're going to need to move at to protect vulnerable customers as we see this enormous transformation of the system. So firstly there on identification, I think the focus here really is making every contact count, making sure that every cue possible is picked up on, so that the needs are fully understood by anyone that we're interacting directly with the person, but also making decisions, particularly as we move to a world about being much more agile about managing the grid, both broadly, but also very specifically in very local areas. Secondly, then about listening to the needs. People's needs, we talk about vulnerable customers sometimes quite broadly, particularly at large events like this one. But to really think about protection, you need to think very specifically about the individual needs, not only of one person, the way they fit into their household, but also how those change over time and how transient that vulnerability may or may not be. Finally, when we're thinking about protecting vulnerable customers and consumers, I just wanted to highlight that the pace is going to be very different in the new world that we're talking about. So there's going to be a lot more decisions made a lot more quickly, and people are going to need protecting in very new ways. So I think it's incredibly important to think about collaborating across the energy stakeholders to make sure that we're always learning and implementing good practice to do with protecting vulnerable customers.
Brilliant. Thank you very much, Elizabeth. That was really interesting and always good to hear from Citizens Advice, who are obviously bastions for vulnerable customers. So next we're going to hear from Julia from UK Power Networks.
Thank you, Randolph. UK Power Networks is one of the distribution network operators in the UK, as you are aware. So at UK Power Networks, protecting our customers in vulnerable circumstances is right at the core of our vision. As part of being a respected and trusted corporate citizen, we aim to be the most responsible, the most socially responsible DNO. And how do we do this? So our strategy is simple. We focus on supporting three customer groups. First of all, those that are on vulnerable circumstances and might be more at risk during a power cut, so with the loss of supply. So we support them by maintaining a priority service register and providing additional support during a power cut. We support those that maybe struggle with their energy bills, so that are at risk of fuel poverty or in fuel poverty, and we set up strategic partnership to tackle fuel poverty together. And finally, we work to ensure that no one is left behind in a changing world. So specifically focusing on innovation, our journey in focusing how we make sure that no one is left behind in a changing world hasn't started now. Really, we set up the first flagship project focusing on customers in vulnerable circumstances and fuel poverty in 2014. It was called Energy Wise, and we explore how best we can work with the local trusted intermediaries to support those that are in hard-to-reach communities. Since then, we have expanded our domestic DSR, demand-side response portfolio, looking at how we can facilitate the uptake of low-carbon technologies for those living in block of flats, for example, with limited space to install these technologies, or those in social housing, looking at how they can unlock flexibility from hot water tanks, for example. We've also focused on the transition of electric vehicles. How can we enable an inclusive transition to EVs, making sure that those that are that don't have a driveway, they don't have off-street parking, can still transition. And we work with local authorities to explore how to enable on-street parking, on-street charging, for example, or looking at what challenges that the SMEs are experiencing for the transition to electric vehicles. But we're always looking at new ways, new opportunities to better engage with our customers that are or may become disadvantaged in the future. So our model for engagement is fundamentally based on embedded partnership with local and trusted partners. So I would like to leave you with a question probably on how can we work together to solve some of the big challenges that we see in this area. And for example, one of the big challenges is identifying those that are most in need in highly urbanized areas like London. So we manage both rural areas as well as London network in London. So if you have ideas on how best to identify them and engage with them, get in touch with us. We would love to talk to you. Thank you.
Brilliant. Thank you, Julia. And great to hear that UKPN's embracing innovation. Protecting vulnerable customers is one of ENA's key pillars of our innovation strategies, which you can learn more about on our stand in the exhibition hall. Okay, so next I'm going to hand over to Peter from NEA.
Obviously, many customers' circumstances are being made much worse by the current pandemic. We know low-income households in particular this winter will be using more, paying more, and probably owe more for their energy supply all the time, whilst potentially earning less. So it's absolutely vital that we all look to up our games in relation to protecting low-income and vulnerable households. And in simple terms, we want the networks to focus as much on the circumstances of vulnerable consumers as they care about EVs, for example. And I'd very much agree with previously Elizabeth saying the starting point for that is to identify vulnerability and looking to do as much as possible through existing good work services register to identify those customers that need support, and then vitally raise awareness of the support that is currently available. And we know that the networks run a number of very welcome programs that can support customers, but we need to raise awareness of that support and use multiple channels to raise awareness of the support that is available in different languages, because we know that the networks service a range of communities that speak a lot of different languages. Independent of that, I think that there's a huge task to do to really understand and act on how vulnerability manifests itself in the day job of energy networks. And we know that the energy networks have done a huge amount to increase the amount of support that's available during power outages, for example. But equally, there's huge opportunities to support vulnerable customers through improving home energy efficiency, to act as an alternative to conventional network. And we know in the longer term, particularly with the move to electric heating, low-income and vulnerable customers will need support to increase the network capacity that they're connected to. So supporting particularly low-income households to increase their capacity of their network connection is going to be vitally important as we move to electric heating. And then finally, I think there's a huge opportunity to put vulnerable consumers at the heart of innovation. We very much welcome the moves in the price control for vulnerable customers to be right at the heart of innovation, either in terms of identifying the impact on vulnerable consumers across the whole portfolio of vulnerability projects, or specifically looking to use innovation funding to address the many challenges that low-income and vulnerable consumers are going to face as we transition to net zero. So I'm looking forward to the rest of the day and hearing other great ideas in this space.
Brilliant. Thanks, Peter. I thought you raised a very poignant point about networks focusing as much on vulnerable customers as we do on EVs, which you're right, we have spent quite a lot of time on. And I think you also are right that is going to be a key focus in the next regulatory period. So I think those were some really good points. So last but not least, we're going to hear from Kevin from the Local Governments Association. Over to you, Kevin.
Thank you very much. We've got to remember, of course, that globally and locally, the people least responsible for climate change, the oldest, the youngest, the least well off, and those with health conditions are going to bear the brunt of this. So we want to make sure that those people are protected in making the solutions as well as in mitigating the effects of climate change. Local councils here are in the front line. We have done a great job during COVID of supporting vulnerable people, so we must be made use of as we have the contacts and we have the staff that are already engaged in helping those people through this crisis. And local councils are developing climate action plans, and in those plans they are aware of the needs of vulnerable people, although they're focusing mostly on heat rather than electricity. But local councils can adopt a whole systems approach to this, using everything from technical innovation to local area planning and electricity, all the developments that are needed to address this problem. We of course provide advice services. So, for example, Swale District Council has recently agreed to contract a fuel and water poverty outreach service to help vulnerable residents reduce their utility bills and energy consumption. A lot of local councils are running citizens' assemblies, and all sorts of questions arise there, as well as concerns. People are really worried that the costs of transforming the energy supply are going to not be distributed fairly, so that they're really concerned that vulnerable people don't end up paying more for this. We have, in addition to the citizens' juries, we have a Property Truth Commission here in Morecambe, so it's really important that the voice, not just individually but collectively, of people who are vulnerable is heard in developing solutions. So, yeah, I think I'll finish by saying that councils are there, we're on the front line, we have a lot of experience supporting vulnerable people. We have a lot, we're building our communication to make sure that the voice of those vulnerable people is heard, and we really must be included in being part of the solution. Thank you.
Thank you very much, Kevin. I personally couldn't agree more with you on the role of local authorities in protecting vulnerable customers and also helping networks identify them as well. So we've got a few spare minutes to ask a couple of questions to the panel. Also a reminder that you can ask questions to the panel in the Q&A function on the screen. So the first question I'm going to ask to everyone is around new technologies. We've already briefly touched on innovation, but I was wondering if the panels could help me understand how we can embrace new technologies to support vulnerable customers. What opportunities are there? Don't know who wants to go first. Elizabeth, possibly?
Thank you. So I think here the first thing to consider is how you make new products and new innovations inclusive by design. So making sure that considering a broader group isn't something that comes at the end where you're quite firmly have already tested, already piloted, and then considering perhaps this is the point that we'll reach out to a particular community, but instead making sure that the new innovational product is at the very beginning considering the needs of lots of different people. So, for example, the research from Citizens Advice highlights that people in the private rented sector and people who don't have a pot of savings and people who are digitally excluded are particularly likely to really struggle to benefit from innovation in the energy system. And so considering those needs right up front can make an enormous difference in making sure that all of society benefit from the transformation.
Yeah, that makes sense. Digital exclusion is definitely a big issue potentially. Would others like to come in on that?
Yeah, I would like to just add on what Elizabeth just said. Fully agree on kind of the principle of vulnerability by or inclusion by design. So making sure is thought through upfront, not trying to adapt a technology, to ask people to adapt to an existing technology. So we definitely agree with that. What I just wanted to add is it's not just about technology. It's really important to understand the commercial model, the business models that are going with that technology. So it's kind of looking at the problem from both sides. So just giving you an example, the projects that I mentioned earlier around how do we make sure that those that are living in blocks of flats, for example, can access those technologies as well, even though they cannot install them in their flats. So that project is looking at an innovative model where the batteries and the solar panels are actually allocated in a common space, are installed in a common space, and then the technology is allocated in kind of proportions of that battery energy storage, of the energy generated proportions that is allocated at the local residents. So that is a commercial model that allows them to participate and take benefit from the technology itself.
Great. Peter or Kevin, want to come in as well?
Yep. Just electric vehicles were mentioned earlier, and an innovative model Lancaster City Council are developing is where we're buying electric vehicles for use during the daytime by staff, but making those available to residents at night and weekends through a car club model. So, you know, there are ways in which we can have innovative models like car sharing that help overcome the problems of residents not being able to park a car outside their front door.
Yeah, that makes sense. Peter?
Yeah, I think technology has a huge role to play. Fortunately, NEA was really pleased to be able to road test a number of technologies 2 years ago through our Technical Innovation Fund. You can see the details of those technologies that we trialled, mainly in social housing on our website. But that those technologies need to be supported by practical and sage advice to households about how to use them effectively, and the wider raise awareness of the wider support that's available for households whilst adopting new technologies to change their behaviours and improve their understanding of how they can own and operate technology and benefit from a range of other services at the same time.
Yeah, excellent. Thanks, Peter. So I'm going to squeeze in one more question, and it's a question that comes up quite a bit and can often lead to Pandora's box, but I'm going to ask it anyway. And that's, how do you define vulnerability and vulnerable customers? If I could ask the panel to comment on that. Let's go in the same order. Do you want to start, Elizabeth?
Oh, well, I'm very glad that you've asked that question, because it gives me a chance to share some oodles of reports in the chat. So I look forward to sharing some of the conceptualizations and definitions, which we found really useful. But the one that I find most useful in my day-to-day work is that it's someone who is exposed to a higher level of potential or actual harm. So if you start with harm and the way that could impact someone, either in a way completely in keeping with others, like not being able to access power, heat, or particularly because of their circumstances, they might have a heightened amount of harm that they experience. But as I say, I will share some of our work in the chat there.
Great, thanks, Elizabeth. Julia, how do the networks tackle this?
Yeah, I think very aligned with what Elizabeth said. Obviously, we adopt often definition, but the key focus for us is obviously harm, with a risk of detriment and harm, but contextualized in the energy market. So how they may experience harm in engaging with the energy market, or barriers in engaging with the energy market, or in using obviously electricity. So as I mentioned earlier, in the case of a loss of supply, that is a circumstance where there are some customers that are more at risk than others. So that's how we identify those that will be eligible for a priority service register. But it's not limited to those. So it's looking at all the possible barriers that they may experience, or the possible detriment as part of the energy system.
Great, thanks, Julia. Kevin, Peter, any final comments from you on definition?
So I think it's true to say that Ofgem have captured the nub of what vulnerability means in their vulnerability strategy last year. They defined vulnerability as when consumers' personal circumstances and characteristics combine with aspects of the market which create situations that they either can't control or are significantly less able to do something about than other people or other consumers. So I think broadly we've got a good handle on what it is to be vulnerable. I think the bigger question mark is, can we raise our game to be consistently doing things to support those customers in and away from best practice to consistent outcomes for the most vulnerable consumers.
Yeah, well said. Any final comments from you, Kevin?
Yes. In supporting vulnerable people through the pandemic, we haven't got too hung up on definitions. We've taken referrals from a whole host of people, but with places like the food banks and so on, the criteria have been loosened up so that people are much more able to self-refer. And the other comment I'd make is that we could all end up being vulnerable at certain times. Health conditions, conditions of employment and things like that. We need to remember that it's not some, specific group. It could be any of us at any time. Thank you.
Yeah, very good points there. Okay, well, unfortunately, I think we've come to the end of our time today with the panelists. For those of you listening, keep the questions coming through on the Q&A, and also feel free to come and find us in the exhibition. I hope you've enjoyed today's session. I think it was really interesting, and as I said earlier, this is a key focus for networks going forward. So we want to hear from you. Like Julia said, we want to see how we can help. So once again, thanks for listening, and we'll see you within the wider conference.
Thank you to all of our speakers and panellists, and to all of you for coming along and participating in today's community session. We'll now be going straight into our new technologies in the real world session, and for this I will hand over to Randolph Brazier from the ENA.